Welcome to Science at FMNH, a podcast and video series that explores the behind-the-scenes science, collections, and research at Chicago's Field Museum.
I'm Peter Makovicky. I'm the curator of dinosaurs here at the Field Museum and also chair of the geology department. And as my title implies, my main research focus is the evolutionary history of dinosaurs.
So I'm Nate Smith. I'm a geology grad student here at the Field Museum and also a graduate student in the Committee on Evolutionary Biology program at the University of Chicago. The research that I'm doing and that the Antarctic program is a part of is looking at patterns of vertebrate evolution across mass extinction boundaries. And the areas in Antarctica that we work preserve two of those boundaries, the Permo-Triassic and then the portions of the Triassic and Jurassic mass extinction event. Paleontology surprisingly has a really rich history in Antarctica, and in particular in the central Transantarctic Mountains where we work. Robert Scott, some of his first expeditions going down trying to get to the South Pole, they actually collected Permian Glossopteris leaves that were some of the fossils that were found basically on their party on their failed attempt to make it back from the pole.
Well, Antarctica is in many ways a unique continent because it's covered by ice. It really has its own sort of physical parameters that you see very few other places on the planet. Antarctica's prehistory has not been as well known and well documented as that of the other continents. Further back in time, we know that this was a continent that had forests and other ecosystems that had animals living on it, but we just don't know a lot about that yet. So one of the principal goals for us to go down there is to try and understand how similar or different Antarctica might have been from other continents in terms of its fauna and flora during the age of dinosaurs.
One of the interesting patterns that we see in the animals we find in Antarctica is that as we go higher in the rock section, or essentially we're going younger in time, we're starting to see the animals get more and more dissimilar to animals in other parts of the world.
So the site we were working on is located in the central Transantarctic Mountains. This is a spine of mountains that essentially cuts across the continent, dividing it into eastern and western Antarctica. The Mount Kirkpatrick Quarry is at 12,500 feet. It's also at 84 degrees south latitude, so it's not only the southernmost dinosaur quarry in the world, it's probably also the highest in altitude anywhere.
At the earliest stage, we're back getting workshops together of various scientists to try and put in kind of a unified front. It's important to remember that paleontology wasn't the only thing going on at this camp. Almost exactly 16 or 17 different science teams worked out of this camp. So a little bit of everything was getting supported, which made it for a really exciting community to be around. Closer to the date when we're actually preparing, then there's much more kind of logistical issues in terms of deciding how much helicopter support we're going to need, what kind of equipment we're going to need down there that we can get in Antarctica versus the equipment that we have to actually ship down, which we have to go through here and check out, make sure saws are running, jackhammers and generators are running, make sure they're crated up properly. All that stuff will actually come down and ship months and months to Antarctica earlier before we get there. The
trip down to Antarctica is quite a lengthy one. From Chicago, you'd fly to LA by commercial airlines, and then from LA further to New Zealand, again, by a commercial flight. Once in New Zealand, you fly from Auckland to Christchurch, and that's where the Antarctic flights stage from. The flights themselves are flown by the United States Air Force usually, although the New Zealand Air Force also flies flights. If you fly with the USAF, you usually go on a C-17 Globemaster, one of these large military transports. It's quite an experience. It's a very cavernous aircraft, and usually one half of its cargo. And you actually land on an ice runway at McMurdo. They have what they call blue ice, which is the hard ice, and that's strong enough to actually carry the weight of the aircraft. So you land on an ice runway. But when you then go from McMurdo towards the interior of the continent, you use smaller aircraft. And the main workhorse of the Antarctic program is the LC-130. So it's a version of the military C-130 transport aircraft that has skis on it, so it can land on snow runways.
So the equipment that we actually take up to excavate fossils with kind of is classical stuff, but runs the gamut from your very basic rock hammers and kind of hand sledgehammers and various chisels to kind of the more ambitious diamond-bladed rock saws and these big 90-pound punjar gasoline jackhammers, and we also, for the first time, it turned out to be a great success, took a bunch of generators up with us and some more lightweight electric jackhammers, which we had a really good time with and actually really did a great job breaking the rock. In addition, every remote team has to have a trained mountaineer with them. So that person is trained in basically crevasse rescue, ice and glacier travel, mountain travel, all kinds of things. So that guy, his job is essentially to come with us to help us decide whether something is safe to do and, to keep the goofy scientists from like walking into a crevasse.
We had something like 6 weeks or slightly less to complete the work on Mount Kirkpatrick. In that time, of course, we lost a number of days to weather, simply weather, clouds moving in and blocking our landing site. The helicopters couldn't come in. Our landing site on the mountain was a fairly narrow ledge, probably no more than 30 or 40 feet wide. We got everything we'd come for, plus more, and so in the end, we were really happy with the successes of the field season.
People are definitely surprised, but getting less and less so. Most of the times when I go and I give talks or I do like public education things, the idea that Antarctica didn't always look like it does now, and the fact that it was coalesced to the continents before and in a different position, I'm finding that through time, more and more people, that's becoming common knowledge. But it seems like sometimes there's more of a leap in terms of you start hearing about these big 15-foot long toilet seat headed amphibians and these large dinosaurs roaming around Antarctica. That's sometimes the more difficult thing to get across and for people to identify with. But it's a great way to kind of get across to folks that Earth history is this kind of vast and diverse thing that we can look at, and things were so different in the past sometimes that we really need that as a context to talk about future change in the environment.